Hey Mark, I hope you're having a good day. I'm Jonah Nickpun, and this is my Lab 1 analysis. So the purpose of the lab was to introduce us to Tracker and Glowstrip and teach us how to use it, and then understand the physical principles behind constant velocity. And in the lab, we rolled a piece of tape down a very slight incline to get a constant velocity, and so at the end of it, our velocity in Tracker, our velocity remained fairly constant, and the position versus time, since we started at the positive x, it sloped downwards. The physical principles behind it, Newton's first law, it caused, since after the initial acceleration to set the roll moving, it didn't change velocity because there was no other force acting on it. And Newton's second law, that initial force caused it to accelerate because it has mass. The system in the experiment is it's very hard to tell, but that's the board, and then it's basically everything else, and the tape is rolling on the system. And then let me show the Tracker video. We have it. It's very hard to see on this just because of glare, so I'm gonna do it at an angle. But as it moves along, we see the red track at different points across as it moves across, and this gave us the data. It produced this graph, which is oh my fucking god, the position versus time, which we see that constant slope downwards. And then so we modeled that using the web Python, and here's a video of our modeling. So it's hard to tell, again, at the angle. The ball moves across the little thingy. And then at the end, we got the two graphs, the position versus time, which, if you can see, you can't see, but it's you can kind of see it. It slopes downwards, and then the velocity versus time, it remains constant right there. And the two graphs were very similar, because we simulated it based off of the initial conditions, which we found by finding the total change in distance over the total change in time. And then on the code for the simulation, we just plugged those initial conditions in and then just ran it through the program, really. The what-if questions, if we change the orientation of the axis, we would get, a different starting point. If we rolled the tape in in another direction, we would get a positive slope instead of a negative slope because it's moving from the negative x direction to the positive x direction. What do the results mean? The results that with the constant graph means that the tape roll, it moved with constant velocity, and yeah, that's pretty much it. Is it possible to find the forces to get to zero? Yes, it is. You find the change in the velocity to find the acceleration, and then you divide the mass by that, and that gives you the force because Newton's second law, and you would counteract whatever, accelerate it in the opposite direction of the second derivative of the position. Not explaining that very well. And then closing, sources of error, friction, because it caused the little wave in our graph because the ball didn't quite roll perfectly constant. And just have a good day. As a final thing, here is my Lego bonsai tree. Have a good day.